Hi there once again and welcome to another Expresso mechanic tutorial, and this is the 9th instalment of Expresso nuts and bolts. In this one we're going to be taking a look at another of the system presets, and on this occasion we're looking at the isSameObject node. Now this is a very curious node, and at first glance you'd think, well, is there really any use for it? But I've found a use, as you can see. So without further ado, let's see if we can make this happen. Okay, so on the screen I've got 8 cubes. Now the important thing is that these are not clones, they're all individual objects. If we take a look at one of them, I've made them 20 by 20 by 20, one segment, I haven't changed any of that in all directions, and a fillet radius of just 0.5 and 3 fillet subdivisions. You can of course make yours any size you choose, but this is what I've chosen to do. So what are we going to do with these? Well, if we get a null, straight away we'll call it Expresso. We'll add an Expresso tag. The window's open a little bit big, so let's just make it a little smaller, and then we're ready to start work. The first thing I need to do, I'll just make this a little bigger so that we can see what we're doing. Open my system presets and come down to logic presets here, and we've got isSameObject. And now let's bring this in and have a look at it. Okay, so we've got 2 ports at the input stage. We can add others here, we don't want to do that. This is a Python based node, so that's why that's the case. So we've got object A, object B, and a result. Okay. So the result, if we check our port information, is a bool. So it's going to give us a value of 1 or 0 or 1, depending on which way you like to say that. And then we've got object A and B. Now, at first, if we just bring in a cube and we place that here, and give it an object port. Now you'd think, because it's saying isSameObject, that we're comparing object A to objects of a similar type. So you'd think you could bring in cube number 1 here, give that an object port, and if we plumb these both in, and then we get a result node, and plumb this in here, you'd think we get 1 because we've got 2 cubes. Well, actually we don't. So that's not the way this works. It's not bothered about whether we're comparing 2 separate items. What you've got to do is actually plug this into here, and then you get the result of 1. So it literally has to be the same object. It's comparing an object to itself. Now, you'd look at that and think, well, what kind of use can I put that to? You know, how can I use that? Well, the way that I came up with was to use lists. Okay, that's how I've come up with it. What we're going to do in this particular example, we're going to use linked lists and place all of these cubes into them. And then from one linked list, we're going to randomly select any one of these cubes and then sequence through the second list, comparing the outputs of both. And once we hit the cube that's been randomly selected, let's say, for example, that it was number 5, and then we've sequenced through our second list until we've reached the index value number 5, we're going to get the same object and we're going to get the result that we want. We're going to get the 1. And then we can use this 1 as a trigger, and we'll use it as a trigger for a monoflop and make something happen. Okay, that's what we're going to do here. So without further ado, let's just continue, just make that 100% again. And what we'll do is start working on the rest of this. So we'll take the cube away, we'll leave this in, and then we can start thinking about what we're going to do. I'll just make the window a bit bigger so that we've got a bit more room. So for a start then, we can actually bring in a couple of linked lists, and I'm going to do that first. It doesn't have to be done in this order, but I'm just going to build it this way. So a couple of linked lists, and then we can populate them. So we'll select all of our cubes, populate our linked list there, just click off the eyedropper, select the second linked list, and we'll populate that one with all our cubes. So we've got that sorted out so far. Now this one we're going to choose a random cube from, and this one we're going to sequence. That's how we're going to do this. So we can plumb these both in to here, and we're ready to go on that score. And then we can think about the first nodes that we need to bring in to make this happen. What we'll do is first of all bring in a time node. It's going to be the first node that we're going to need. We're going to need frame port as well as time port on this occasion, so I won't take the time port away. Moving on from here, we'll bring in a math modulo. So this will be a modulo, and we're going to modulo the frames. That will be the input on input 1 there. And we want this to trigger every 30 frames. So every second, what we're going to be doing is sequencing through this list. We're going to be pushing out a new index value. So starting with 0 through to 7. In fact, we'll rename this cube 0 just to make that easier so that we can see the index numbers. So that's the first thing we've got in there. The next two things to do will be to bring in two compares. So I'll just come down to logic compare and then command drag to create a second one. The first one here, we don't need to do anything with. Again, we'll use frames for the input 1s on these. We'll just use that frame port. This one we can leave it equal to 0 because this is going to be used to reset the counter of a monoflop node that I'm going to be bringing in shortly. And this one will need to be greater than or equal to 30. That should work fine. In fact, I'll make it equal to 30. We can then bring in a bool because we need to check that both of these conditions have been satisfied. So we're going to bring those two in there. Our function we can leave as AND because that's correct. So we'll set that up like that, and then we can bring in a monoflop. And as I just mentioned, this is only going to be a counter, so at the output stage I just need the count, and we need the out too. We're going to be using that a little bit later. We can plug our bool into the trigger, and we can also set the monoflop up as a one-shot monoflop because we want this to trigger when a 1 comes out of the bool. When there's a 0, we don't want it to trigger. We don't need a time or duration because we're only using it as a counter, but we do need a reset, and we need to plug the output of this compare into the reset so that when we're at frame 0, we reset the counter. And that's our first monoflop completely set up and ready to go. So the next thing we need to do is plug it into the index value here. And this will allow us to count. I mean, if we put just a result node here and we plug this into here and we run the timeline, we'll start to see, at least I hope we do, that we actually start to count. Let's have a look, see if I've got anything wrong here. So what am I doing? I'm comparing to equals to 30, modulo 30, bool, and I've got a trigger in there. See if I've done anything wrong. I hope I haven't, but I can just double check. Yep, I know what the problem is. I was right to say greater than or equal to 30. That's why. It can't go on equal to because it just won't do it. But if we run the timeline now, it does count. It waits for 30 frames and then it counts. That's what I wanted it to do. Okay, so you can see that that's working. It's counting from 0 to 7, which is exactly what we needed to do. And then when we loop, it resets. So that's fine. That's all working as it should be. So let's just take that result away. The next thing to do is think about a Python node. So let's bring one of those in. You weren't expecting me to do that, were you? No, there is a little bit of Python involved in this. And what we've got to do is remove the two input ports. I'll also remove the output port. And as per usual, start again. So what I want here is an integer. It needs to be renamed and it needs to be called frame. Because again, we're using our frames as the input. Don't worry about that going yellow. We just got to put an integer for the output port. We'll rename it and we'll call this index. So we're going to randomly choose an index value, as I said before, and then we're going to feed that into here. Now, if we just move this out of the way, go to a scripting layout, and do the usual rigmarole of going through this again, selecting this and opening it in there. I do wish they'd make that simpler. But anyway, there we go. So we've got a global index in there, and that's the only thing we need at the moment. We don't need the next line, so we'll take that one away. And then we can think about doing the rest of our Python. The first thing we need to do is come up to the top here and say import random, because we need the random module from Python. Moving on from here, I can say global RND index. So global random index, and that's going to be a list that I'm going to create very shortly. So we've got our frame input here. So we can say if frame is equal to 0, so if we're at the start of the animation, I can then define random index. So RND index is equal to an empty list. That's what it needs to be initially. Moving on from here, the next thing I'm going to do is actually define a function. So I'll say def generate random index. So generate underscore random underscore index. I know it's a bit of a long definition, but it does make sense. And then we can define this function. Now, I didn't think it was actually possible to define functions within the Python node, but this goes to prove that it actually is. So that's something new that I've learned by doing this, so something that's well worth knowing. So RND for random is equal to random.rand int brackets 0, 7. We want to generate a random integer between 0 and 7, which of course corresponds to these numbers here, so the index values of our cubes. We can then say if len, and this will be random index, so if the length of our list here is equal to 0, so if there's nothing in this list here, we want to put our random number that we've just generated in there. So rnd index dot append, and it will be rnd to place our random value in the list. So we only want one number in there really at any given time, and that's all we'll get actually, because this will only be generated at frame 0, because we're going to put that in next, because in here we're going to say generate random index and call the function at frame 0. Moving on from here, we can say index. So in other words, we're going to output this here. Index is equal to rnd index square brackets 0. So whatever we've placed here, we're going to output here at the index. And then to finish this off, we simply need to say else, and then copy this line into here. And that's as much as we need to do in the Python. So we're simply going to generate a random number when we're at the beginning of the animation and output it here at all other times. So we will output it at frame 0, but we're also going to output it at any other point along the timeline. Okay, so that's the Python dealt with. Let's just execute that, and it says we've got no errors. Just make sure there's nothing in there. Run the timeline, see if anything happens. No, nothing seems to be amiss. So we can test this out. If we just bring our window open again, so a bigger size, we can test this out. So if we place our index value into the index of the linked list here, we can get another result node, plumb this into here, and we'll see if we get our value. Now let's just do a double check. We'll get an index value here. So okay, at the moment we've got an index value of 5. That's what we've randomly chosen. So let's just run the timeline. Well, we've got an index value. Okay, so we've got an index value of 1. So we're at 44 frames, which means, I mean, we will count to 1 on this monoflop if we just bring this in here. Yeah, we've counted to 1, and they all correspond now. So we've got 1 here, which means we've got 1 in this index list. We've got 1 as our random value, and we've got a 1 as the result of our same object. So it knows that it's selected the correct object. So that's how this is working, and it's all working really well. So that's great. That's what we want. So we'll remove the result nodes, and we can think about working on the next stage of this. I'm just going to tighten this up, actually. Just bring those over there so that we don't take up as much room. Okay, great. So that's the first little bit of it done, and we can move on from here. The next step is to bring in another monoflop, which will be triggered by the isSameObjects output here. So let's get one of those, and we'll place it here. We'll just move that along a little bit, give ourselves a bit more room. Straight away, I'll put the trigger into, or plumb the result into the trigger, and I'll also change it from a normal to a one shot, because again, we want it triggered by a 1. The time we need to bring in from the time port, or the time port of the time node, the time output port of the time node, that's what I'm trying to say. That needs to come in from there. We'll just move this down a bit so that we can see what we're doing. The duration now, don't be tempted to put 30 in here. It should be 28. If you go 30, you'll cause problems. So, make sure you allow a couple of frames. And we'll also add the state this time, because we want this to be controlling a range mapper, which is the next node we're going to bring in. So we'll get a hold of our range mapper and bring this in. Now, the input value range, or the input range, can be 0 to 1. That's fine, because that's what's coming out of the state. The output, I'm going to say 0 to 21. You'll see why in a moment. And then what I'll do is bring in cube 0 here and give it a position Y input port. And now that's ready to be moved via the range mapper. It also needs an object port, because this is actually just a placeholder for the cube that we're randomly choosing. So we've got to plumb in the output of this linked list, which is our randomly chosen cube, into here. Just move that up there for a minute, and then bring our range mapper in here. And let's see if we get a result. Just take that back to 0. And we do. So we got our 4th cube raising there. So that we would have had an index value of 3. So this was the cube that moved. Now at the moment, it's not moving the way we want it to. And that's because we need to set the spline up in the range mapper. So what I'm going to do, I'm going to give the range mapper's spline 4 points. I'm going to set, if we toggle this open, our initial point here at 0 on the X and Y, our final point at 0 and 1, so 0 on the Y, 1 on the X, and then these two will set up accordingly to make a bell curve. Now, if we get a hold of this point first, what we'll do on point X, we'll say 0.25 and 1 on the Y. With this one, 0.75 on the X and 1 on the Y, and that gives us a shape that we're wanting, but we need to do some work with the tangents. So we've got over here, what have we got on our tangent? So 0.25, we'll do the same with all of these. So if we say minus 0.25 in there, that gives us that one. 0.25 there is fine, and 0.25, or yeah, I'll just try 0.25, see if it works. No, it doesn't. It needs to be minus 0.25. Oops, not very good, is it? So let's just move that back. Oh, actually, I've done that wrong. Sorry, apologies there. I didn't do the tangent. That should be minus 0.25. That's better. That's right. So now we've got the same thing there, and we've got minus, that's 125, so let's minus 0.25 that, so that we get the same thing. And that way we've got it consistent all the way through. So what we'll do is, just to test this out again, is we'll run the timeline, go back to 0, run the timeline, and see what we get this time. And we've got it. So this time we got our 5th cube along, so it would have been cube number 4 here. And that worked beautifully. That did exactly what I wanted it to. So great, that's all set up. It's all working as I'd like. The next thing that we can think about is changing the colour of the cube. So what we'll do here is go into our basic properties and select colour. And we'll just move that into the centre there. Make this a little bit bigger. So how are we going to do this? Well, I said that we would use the out of a monoflop. I mean, initially I said I was going to use this out. It's not this one that we need to use, actually. The one that we need to use is the out from this one. So in order to do this, we'll get a condition node, come down to logic condition, and we'll plumb the out into the switch. But we must change this condition's data type to color. So we'll come up to color and select that, and then we'll give it a couple of colors. Well, at the moment, what we've got, if I select one of my cubes, go into basic here, I can just hold down my control key and select copy to copy the color, and then do the same again and hold down my control key and paste that color into there. And then in here, I'm just going to select yellow. So I'm just going to make it that color and leave it as that. And then we can paste, or rather plumb, this into the output, or from the output into the color input of the cube. So let's see if this works. And indeed it does. So that's selecting a different color for us. Now we can make this more interesting if we bring in a second condition. I'm going to firstly we'll copy this one, actually command drag to copy this one and just place it over here, and I'm going to give this another 6 input ports and then open it up to a bigger size. Now this will actually be used to switch the colors according to which index value has been chosen by the Python node. So we're going to plumb the output of here into the switch there. Now at the moment I've got 2 colors. I'm going to just change these. I'm going to there and we'll make this a basic red. This one we'll make a blue. Well, in fact, I'll tell you what, we'll leave that as yellow. We'll make the third one a blue. We'll make an orange. So if we go there and make this 128, we'll get an orange. We'll look at making this, I think, a green. We'll make a pinky colour. And we'll make, let's have a look, see what we've got. We can make a purple by going there. That'll be fine for a purple. And we'll make, well, I mean, we could make a white, couldn't we? Just leave that one as a white. Okay, so we've got a variety of colours there that we can choose as according to which index value comes out of the Python node. That's ready to go. So what we can now do is plumb this into here. Okay, so that's all looking good. let's see what this gives us. Okay, that's great. So that's chosen that colour for that one, which is right. And orange for there, that's fine. So that's all working quite nicely. But yeah, I mean, so, you know, this is effectively the end of the tutorial, because this is what I wanted to show you. And this is a possible use for the isSameObject node. I mean, there's quite a lot going on here, and it's quite long-winded to set this up. But nonetheless, it all works perfectly well, and it does give you a use for this particular node. Maybe you can come up with an idea for something that's more interesting than this. You know, certainly if you wanted to, say, select a random cube every 30 frames with a different color, you wouldn't need isSameObject, because all you'd need to do would be to use a random number, trigger it every 30 by using a modulo within the Python node, or you could even use the math modulo and feed that as a trigger into the Python node. That would generate a random number every 30 frames, and then you'd simply output the index value to the linked list and choose it, and again switch the condition for the colors. So you could do that far easily. It's far more easily doing that. But if you wanted this timing, so if it was the first one, it would trigger straight away. If it was the second one, it would wait 30 frames. It would wait 60 frames for the next one, etc. If you wanted that timing, then this setup is ideal for that. But it just depends on what you're trying to do and what you're looking for. But anyway, you know, that's what I wanted to show you in this tutorial, and that brings it just about to a close. So as always, I hope you've enjoyed this one, and that it's been worthwhile, and that you've learned something new that you can use in your own projects. And if you have, then please like the video and give it a thumbs up. And of course, if you haven't subscribed to the channel already, then please do so. Leave a comment and ring the bell. And wherever you happen to be on social media, then please share this video, because all of this good stuff helps to keep the channel moving in the right direction. But that just about wraps this one up. So we'll have a final look at the expression. Just frame all so that we can see everything there. Just get that to a good size. And let you have a look at the code. But anyway, I'll see you very soon on the next tutorial.